Hi, everyone, and welcome to today's webinar on LiDAR. As most of you know, LiDAR is certainly growing in its use and its importance in terms of resource road design. Now, we've made a few changes in our newest version of RoadEdge that can impact how you can work with LiDAR, including a new 64-bit platform and smarter data thinning functionality. So in today's session, we've got Fred, one of our account managers. He's going to be doing a bit of an introduction with some tips and techniques for working with LiDAR. And then we're going to pass it over to Jack, one of our applications engineers, and he's going to show you a design from the start to the finish, including the thinning. And then, of course, setting up some real basic stuff in our location module for how you can design your roads better. So with that, I'm going to pass it over to Fred, and we'll get started with LiDAR.
Here's a brief outline of what Jack will be covering in today's webinar, which again is LiDAR-based resource road design. Jack will go through a few key steps. First, importing LiDAR data, then LiDAR thinning techniques. This is to ensure the software is doing the calculation as fast as possible while maintaining the important data points. He will then generate a 3D model, taking horizontal alignment, the vertical alignment, and a little bit of balancing of the earthworks. Before we get started on the demonstration, I wanted to quickly introduce 3 concepts that can help you make the most of your LiDAR data. As you know, LiDAR can be quite large files, and the larger the set, the longer calculation process. So in order to ensure you take the most advantage of your LiDAR set, there are 3 rules or principles, if you want to call it, we can use here. First rule or tip is to avoid the gridded data. The key point here is around the back set. Basically, you're not getting any new information. You're just adding a ton of new incremental points. Don't use your pre-processed data, and just use your raw LiDAR file. The second tip, which Jack will explain in more details, is the idea of selectively thinning your LiDAR data around the area of interest, which is basically the corridor you're designing. This allows the full resolution where needed and lower resolution outside the area of interest. You can later go back and bring that area back into full resolution. With version 8, there are new methods of thinning. These are now done after data import and results in more accurate surface representation. The first new method is basic grid simplification. This is the middle figure you're looking at. This is a pretty fast method. You define a grid size, and the data is thinned to keep 1 point per grid. Of course, you can still define the area of exclusion. The second method is closest point removal. This thinning method utilizes both minimal distance and defines simple grid size. This is the farthest right figure you're looking at. Multiple points per grid can be pertained if they are further than the minimum distance. The minimum radius is represented in the first grid cell by the green circle. Neighboring points within the cell that falls in the radius are removed. This method is considerably slower than the basic grid, and in this case, I recommend setting a radius smaller than the grid size. Both these methods result in a more accurate surface representation than we had back in version 7 on importing option. The third tip which works only with the ASCII data set, is around grouping the data. You can combine features when importing your data in order to save memory. Jack won't be covering this as he's going to be using a LAS set, which already has this function automatically embedded as importing. That being said, that's it for me. I'll let Jack to take over and show you how to use LiDAR in version 8.
Thanks, Fred. One more thing I'd like to say. I think Fred already said it, but there is a chat dialog box. If you have any questions, you can always just ask a question and I'll just verbally answer it. Okay, let's start by importing some shape files. I'm going to use the shape files to thin out the data after we've imported it. Like Fred said, the new way of doing things in version 8 is by importing the data set with full resolution. Let's just import the road network first. Now the data set. Insert the data set with full resolution. So all the LiDAR points, I got about 6 or 7 of them there at the same time. Just select them all with the Shift key. Press open. Okay, in previous version you used to do your thinning here. It's not as accurate as the version the method that we have now in version 8. So we don't use it anymore. But yeah, so this is just a random thinning. It's not as accurate as the thinning that we have right now, which Fred explained. So I'm not going to go to this tab in the LAS import options tab. I'm just going to make sure do not have display points turned on, and it's good to keep your extent borders off if you got multiple tiles, as I do. And you don't want to obviously turn on all data points because you just want the ground information you plan on doing design. There's a whole bunch of different layers here. Obviously, most people want to just turn on their ground data and import that data. So let's just let her go and import. It's telling me that coordinate system is different. That's fine. This method, the importing process is quite fast. What used to slow it down before was when we used to use that selective thinning dialog box. So it's much faster to just import the data and then just thin it out after. So it's going through all the tiles. After it's done, you should see a swath of pink or magenta. There we go. Should see a swath of pink or magenta, and there we go, we're seeing it. Now we can do our thinning process. If I select on blank screen, it will all the data will disappear. It will be hidden. It's still there, it's just hidden. Let's do our thinning process now. The after import thinning. Terrain modeling tab. Simplify button. Okay, so these are the two methods that Fred mentioned, was the fast method and the slow method. The one that I'm going to use is the one where you just specify a cell size, and I'm going to keep the cell size as 10. And I'm also going to do one extra step, is I'm going to add a couple of areas of exclusion. Corridor, select. Proposed road 4. And my distance of exclusion area is going to be 100. This is an imperial file, so the distance of exclusion is going to be 100 feet on either side of that corridor, or on either side of that line. Press OK. I'm going to add another one. Corridor, select. Scroll down until I get to proposed road 6. OK. The bottom part of the dialog box allows you to calculate how much you're actually going to be thinning. I'll do that just by clicking the calculate button. It should give me the amount of data thinned and also a percentage reduction after it's done. It takes a few seconds.
Jack, while writing, would you like to answer some of the questions?
Oh, wait a moment. Do we see questions? I'm in
this one says, does the temp represent meters?
It represents whatever units you're working in. if you're in, I think it is 10 meters, yeah, or in this case 10 feet, because it's imperial. It's an imperial file. But if you're working in metric, it would be 10 meters, 10 meter by 10 meter cell size. Okay, so we had originally 5,828,000 points, and we reduced it by 86%, so we got 761,000 points remaining. All right, so you can see that most of the data has been thinned, except we've got that 100-foot swath of data around our two roads that I've kept at full resolution. All right, now click on blank screen so data is hidden again. Don't need to see it. Next step is to generate your tin contours. I'm just going to do minor contours. I'm not going to worry about major contours. And I'm going to set my minor contours at 5 feet. Notice this number is a calculation range, 1248 to 2583. That's the elevation range that we have in this file. So we should be, when we set our start interval, if you want to contour the entire file, you should set it just slightly below this number and end it just slightly above that number. So I should go at 1240 to 2590. Press OK. It's telling me that there's a couple of features. There's a few features that are outside of our tin. That's fine. Oh, well, sorry about that, Les. Okay, now that we've got it contoured, all right, now that we got it contoured, let's just take a quick look at it in 3D, just because it's just a little, just to show you what it looks like. Probably going to be a lot of data, but we'll just take a look at it. Just, there it is. It's a nice file. Okay, I've got this file saved. I'm going to show you how to start a design. I'm not going to finish it. I'm just going to show you how to start a design. Open up a new location design, and then I'm going to go to a finished design and show you how much it costs. Press new file. In the latest version, when you press new file, you'll be entering a splash screen that looks a little bit different than the previous version, than version 7. Choose your terrain surface or your P-line traverse, whichever one you have. In this case, I have a terrain surface. Or you can choose a land XML file if you want to. I'm going to open up this file that I just used. Road 6 is the one that I want to design. And then once I press OK, it's going to ask me where do I want to start. I've already selected the beginning of the road. So I'm just going to start at that terrain current point. And I'm just going to use the default template that I have in there, and I'm going to change my templates later on once I get in. So where's the road starting? Okay, so I'm starting my design right there, which is the start of that road 6 that I thinned earlier. Retrieve a screen layout for horizontal alignment. I'm just going to do a small section of road of horizontal alignment, and then I'll show you vertical really quickly, and then I'll show you the costs. Training curve H is a good screen layout for horizontal alignment. Before I do any kind of alignment, I'm going to change my template to a low volume resource road template. You go home and then you open up a table, go to my training folder, low volume English. Since this is a imperial file, I'm using English. Turn off some of these labels. Okay, so there's the road surface ditch and cut and fill slopes. Okay, now let's quickly show you some design. It's the same as it was in the previous version. Nothing has changed here. Left click. I'm just going to zoom in, turn off my lock scale, and zoom in so I can see the road a little bit better. Follow it along. Come up here. Sorry, I should be starting at the and click down here if you want to attach at that point. Left click twice, just like in the older version. And then I'm just going to finish off by going through this straightaway here. And I'm going to go just straight through. I'm not going to go and worry about any kind of curves there. Jump back. Put in a jump back all the way. Just hold on. Jump back to this. Put in a 60 radius curve. Apply. Move that curve a little bit away because I know I'm not going to be able to fit the other one in. Get my default. Yeah, it's not fitting in, so I'm just going to move this away a little bit more. Okay, let me try something smaller. 50. 50 works. Let me set that as my default. Jump back, get my default, apply. All right, 50 seems to work. Let me just leave it at that. Push those two curves so that they're touching. Jump forward, get my default, 60 back here, apply. That's pretty good. Let me just change it slightly to 70. That's not bad. Get rid of that north arrow. All right. Jump forward. I don't need to put a curve here. It's pretty straight. Okay, let's go do some quick vertical design and I'll show you some costs. Get a screen layout for vertical. Pretty steep. Let's see what the grade is. 15.4%. If you need to stay lower than that. A lot of the interior roads, at least here in where I'm from in BC, I guess 15 is probably the maximum that you can do. Let's try some more IPs here. I'm just doing long straight segments I don't need to worry about. I'm trying to balance as much as possible. That's 12%. Perfect. End up here. Maybe put one more IP down here. Put in my curves. Get my default. I'm going to put in a twin 20. Sorry. 20K. Set that as my default. Jump forward. Get my default. Apply. Jump forward. Get my default. Apply. Jump forward. Get my default. Apply. Okay. Okay, so like I said, nothing has changed really too much here. I'm cutting a little bit too much, but I'm going to fix that problem by moving my alignment up. Try to balance a little bit better. I'm balancing quite nicely now. Starting to balance quite nicely. Pull up my alignment here. A little bit too high. Pretty well balanced, I think. Yeah, I just got about 50 cubic yards of material that's being thrown away. Not bad. Okay, let's take a look at how much this road costs and just manipulate my vertical alignment just to, and my horizontal alignment, just see how the costs change. I'm going to turn on the auto calculate, and notice the cost is, this is a pretty cheap road. I didn't do too much to it. It's pretty short segment, so it's only about $1,400, $1,500. It's not a big expensive road based on these costs right here. Let me show you, I'd prefer to show you a different road. I'm going to shut this down and just show you a completed road that I have that costs a little bit more, $71,000, because it's all the way to the end of the design. Manipulate the vertical, cut less, try to balance a little bit more. You can see that the costs are going up and down. As I cut more, costs should go up. They do. As I fill more, costs should go down. So yeah, it's costs a lot more to cut and to fill. And these costs come from our dialog box here, unit costs. I am basically using this overburden, this common material, $12 to cut, $4 to fill, and that's where those cut and fill costs come from. And you can also change your horizontal alignment, obviously. Let me just change that, and the cost will also change. Let's say you wanted to try a different, slightly different route, or a different route totally. And see the cost changed again. If I pull out a little bit more, it's at $132,000. Now it's at $135,000. Try cutting a little bit less here. Sorry, avoiding less, just going straight through instead of having to worry about going around these contours. Now it's $146,000. Anyway, you guys got the idea. That's how you can calculate. You can see that I'm cutting a lot more. So I'd probably want to go back to my vertical and fix that problem that I've just created, wherever that is. Let me just zoom in. I'm going to go back a little bit, forward a little bit. I think it was right here that I created that problem. Cut less. Good. Anyway, you guys got the idea. That's where I'd like to end it. I just wanted to quickly show you how to start a design and to show you how to calculate your cost. The costing portion of our alignment panel comes with RoadEng. So you can cost out a road if you want to. Just remember, do not, if you're going to do a manual design, try not to change the cost too much because you want to compare one alignment to another. You don't want to keep on changing these costs and then have your alignments not jive, or sorry, your costs not jive. All right, thank you very much, and we'll see you guys in a couple weeks for our next demo. It was a pleasure. Thank you.